Right, this is sheet 3, question number 5 from VCAR 2019. So we have this cubic, domains all real numbers. The tangent to the graph at x equals a, where a goes from 0 to 1, so we're only attaching the tangent somewhere along here, touches the curve also at P and has an x-intercept at Q. The shaded region shows you the diagram below is bound by F, the tangent, and the horizontal axis. Okay. Find the equation of the tangent to the graph at x equals a in terms of a. Okay, so let's put in 1 minus x cubed, and let's find the calculation of the line of the tan line at x equals variable a, and that gives me an answer which is y of the tangent is going to equal, I'd like to put the gradient bit first, so minus 3a squared x plus 2a cubed plus 1, but you could write it all out like that, but just make sure there's a y equals. Find the x-coordinate in terms of the x-coordinate of q. So this is my equation. I'd like to set that equal to 0 to find the x-intercept and solve for x. And that gives me, if I simplify that, maybe if I take that and combine it into 1, so that gives me x equals 2a cubed plus 1 on top of 3a squared. So that point there is 2a cubed plus 1 on top of 3a squared and 0. And find the x-coordinate of point P. Okay, so I'd like to find the intersection point between this line, keyboard, copy, paste, equals my tangent line, which is this line here, copy, paste, solve for x. Now I know there'll be one answer and it will be at A. And that made sense, x equals A, because I knew that x equaled A, that was one of them. So the other one is minus 2A, so it's going to be x coordinate x equals minus 2A. So that does A, B and C. D says, let A be the function that determines the total area of the shaded region. Find A in terms, okay. I'd like to consider this as being two things. I'm going to consider the region between P, Q and this line here, and that will be, so this is the first bit, so the large triangle, but I'll use an integral to do it. So the area is going to equal the integral from minus 2a through to 2a cubed plus 1 on top of 3a squared of my tangent line dx. And that will give me all of this. And from that, I'm going to minus the white bit, which is the area under the function from minus 2a to 1. And that should give me an expression for the total area. So let's do this on the calculator. Here is my tangent line. If I can pick it all up, I can. And I'm going to integrate it. My bottom value will be minus 2a. My top terminal will be the x-intercept. And then to all of that, I'm going to plus the integral from minus 2a to 1 of 1 minus x cubed dx. And if I simplify that expression, and maybe if I take the answer and I combine it all together, that gives me that expression. And of course, I don't want to combine them. I wish to minus the white bit, which gives me this expression. So the area equals 80a to the 6 plus 8a to the 3 minus 9a squared plus 2, all on top of 12a squared. Where is that going to be minimum? If I take that expression and I go interactive, calculation Fmin in terms of A, and I know that A goes from 0 to 1 because it was defined earlier in the question. And that gives me an A value of A equals 1 on top of 10 to the 1/3. So Fmin of A, small a, 1, 0, 0, 1, will be my method for finding the minimum value of A. Consider the region bound by, so that point is going to be here somewhere where I've got 1 on 10 to the 1/3, and my Y value for that will be, so if I grab this, copy, paste, and math3 given x equals 1 on 10 to the 1/3, I get y equaling 9/10. Okay, so if I now have in the last bit, consider the inverse of f of x, the tangent to the graph of the inverse, x equals b, and the vertical axis. That's an inverse of what's going on here. Instead of, okay, so it's just the inverse of that function, which means the value of b, if we swap our x's and y's over, then the value of b is going to be 9 on 10. And part G, find the value of the acute angle between the tangent to the graph of f and the tangent to the graph of the inverse at x equals 1. So the tangent to the graph of the inverse at y equals 1, the tangent is a horizontal line of f of x. So if I'm going to do the tangent to the graph and the vertical axis, let's think about this. So let's think about the inverse curve. The inverse curve is going to be vertical here. It's going to cut through at 1, halfway, some point between 1 and Q, and then go down. So it's going to look like that. Then it's going to go through point P. So this is the inverse of F. And we're looking for the region between the tangent at x equals b. Tangent at x equals b. So the tangent at x equals b is going to go through point Q and point F and be tangential. So that's at b. And b is going to be the inverse, so it's going to be 9/10. That's going to be 1 on 10 to the 1/3. Okay, so that's what that is. Find the value of the acute angle between the tangent to the graph and the tangent to the graph on both at x equals 1. Both at x equals 1. Okay, so for the inverse at x equals 1, it's a vertical line. Therefore, the angle is 90 degrees. Because at x equals 1, it's a vertical line. So that angle is going to be 90 degrees. And I want the angle here on this curve. So I need to take the derivative of that function, and that function is 1 minus x cubed. And I'll take the derivative of that. Derivative, diff. And given x equals 1, then this angle here is the inverse tan of -3. So I'm looking for the inverse tan of -3, and I've got 90 degrees. So I should be looking for pi on 2, want this angle here. That will be a negative answer. So plus the inverse tan of -3, or pi on 2 plus the inverse tan. No, I wouldn't be plussing. I'd be minusing. The inverse tan of 3 will be my angles. Either of them would do, because we're looking for this angle in here. And I know that that is the inverse tan of -3, but that's a negative value. And I know that that's pi on 2. So this is the value I'm wanting. So it's going to be this minus that, or this plus the positive of it.